Everybody, my name is Yahya Ithawi. I'm a consultant neonatologist here in Saudi General Hospital Ajman. And in this short video, I'm going to talk with you about NIRS, the Near Infra Red Spectroscopy, which measures the local tissue oxygenations. And I'm going to talk a little bit about the setup. So you can see that the NIRS, or Near Infra Red Spectroscopy, is a small size machine which has a monitor. And it's connected by a wire to the adapter, and from the adapter to the baby. And you can see that we have two channels. We are recording the forehead. From the forehead, we are recording the cerebrum. And we have other record. I put it on the kidney, so it will represent the somatic. It's very easily to set up. It have two probes. One is emitting and one is receiving, and it records in an arc shape. They call it banana shape, and take the tissue. It measures mainly the tissue oxygenation, which is more venously weighted, not like the pulse oximetry, which is more arterially weighted. So if you can see that the saturation, this is the saturation, right? So if you can see the saturation here is 100, and the saturation here is 92. Which means the brain only taking 8%. The brain is very resting. Okay, so you can see the brain ox consumption rate is very tiny and is very high. And you can see the brain record is very stable, while the somatic record usually is variable. Now start to be more variable when the brain is suffering. But because now the brain is very comfortable and not suffering, the somatic is less variable. So you can see that the second channel, which is recording the kidney as an example for somatic, usually it's variable, goes up and down, because they have auto-regulation. And so because the somatic is always work to compromise themselves to save the brain. And you can see that now you can set your alarm. You can see that the alarm here, if it goes below 40, it will start to alarm. So usually the normal values for the brain is less variable, and for the somatic is very variable. The difference between somatic and the brain should be less than 25. Okay? So if it's more than 25, then probably you have a problem. And also it's usually somewhere between 50 to 80. So if it's more than 80 and you're providing oxygenation, you are probably over-oxygenating the child. But if it's below 50, then it's alarming sign. And it does not affect only by oxygenation, it affects also by CO2 level. So let's say you are transporting a baby and you're giving hand ventilation, you're doing it because you're anxious, doing it quickly, you will wash CO2, you affect the brain flow, and therefore the saturation will go down. So it's a very good predictor for hypercapnia, hypocapnia, and for the oxygenation. And the only challenge is to keep it fixed. So you can see when the child cries, we will disconnect. So the challenge is to keep it fixed on the head. So you can see that you can set your channels, you can name your channels, you can set your baseline values, you can set your alarms. You can set your time, like how many. You can see the whole record here is over 1 hour. You can make it over 30 minutes, over 1 minute, so you can see more detail. And you can see this is the somatic. You can see the variability, and you can see this blue color is the cerebrum, which is a little bit less changing. Okay, we're now disconnected, so it needs time to re-record. Oops, we're vomiting. Yeah, so basically it's very easy to set, but have a great values, and we will do more videos about it and show you more. There are many machines in the market. This is one of the machines that here is available here in UAE, and it's really a valuable machine because it measures the local tissue oxygenation, especially of the brain. When we do resuscitation and we have a sick baby, our main target is actually the brain. But guess what? We usually don't measure the oxygenation of the brain. And because it's more venously weighted, the difference between it and the pulse oximetry, which measure more the artery, give you the oxygen consumption rate. So you have oxygen consumption rate, you have the oxygenation of the brain, and you have oxygenation of somatic. The first things will be affected is the variability. If you lose your variability of the somatic, then you start to have a problem. And this can be about 6 to 8 hours before you can see the sign of shock. You can also present it in a smart way, so take the data and present it in a histogram, or present it in a tachogram or a point curve. And they will give you pictures, you can see if it's skewed right or skewed left, or scattered or centralized, and this will give you more ideas about the performance of various procedures that you use to help this baby, whether it's a cardiovascular or it's a respiratory. Yeah, so we will do more videos, and we'll see you in the next video. Thank you very much, and enjoy the rest of your day.